All right, so let's make a start and see what we have for today. First, my name is Dr. Aliyuda, and I will be part of the teaching team for this particular course. So hopefully, uh, I will see you in the second semester for some of the modules that you will be taking in the course of your program. So we are looking at introduction to just some basics of data and information, and also some packages or some tools that you'll be using to explore the data set that you may come across and also extract some information from them. So today is just basics and it's more of information. We are not going to do some practical works today. So the big question here is, what is data science? And as Mariam was saying in the morning, we shall be using the open data set for all uh, data to at least implement some of the model that we shall be developing in the course of this course. So the motivation for the course is data is driving everything. Now, if you look at every sector, you will discover that the most important thing which all sectors today is data. So data is being generated in different forms. So modern data acquisition is inexpensive. Why? Because today you can use your smartphones, some embedded systems to what? To acquire data set, to gather data sets. And then also some medical devices, simulators. Sometimes you just be doing your normal day activities, but you don't know or you are not aware that your data is being collected. And also, the cost of storing data set nowadays is inexpensive because we have what is called the cloud and other facilities or storage facilities that are inexpensive to store data. And then what about the computation? The computation also is inexpensive because there are a lot of technologies. For instance, we have the parallel computing. So in a nutshell, you find out that you can acquire data set, you can store them, and then you can carry out computation on them. And now the question is, can we use algorithms plus data to understand phenomena? Or can we build or augment models? Can we also build detectors or make diagnoses from this huge data set that we are able to store and also to process them? And what are some of the key questions in data science? And one of it is, how do we explain and predict the world around us, or the environment that we live in? How do we explain it and then predict it using data analytics techniques or skills? Much of science and engineering are derived from physics and also mathematics as well, where we have rich predictive models. So in physics and mathematics, there are established models. There are models that have been established already. For instance, you have the Newton's law, the theory of relativity, optics, how materials react under stress, and so on and so forth. So the basic of prediction tends to be simulation in these areas of engineering and science. So how do we make predictions where we don't have a good model or we don't have an underlying model? For instance, in human behavior, we don't have models like that. Or let's say some biological processes, let's say the brain, whether a product will be a success or what to invest in it. So there are certain uh, situations or circumstances or domains where we don't have already established models or laws or theories that we can use to simulate such behaviors. So in this case, we need to use sampling or statistics and then data-first approaches. But we need enough representative of data and the right question for good models. Of course, in the real world, we often want to combine models to data. So in these situations, when we have data in such domains, we don't need already established laws or principles or theories. We can use uh, data science skills and techniques to model such domains and then also to come out with information that will be useful to the world and humanity. So, outline of the presentation today, we look at what is data science and then considerations around big data and what those analytics involved, and disclaimer and recap, some checkpoint exercises, practice notebook, which maybe you can do on your own. So let's dive into it and see what we have. So this is what we call word cloud for data science. Don't worry if you are not familiar with the concept for now, but in the course of your program, you will come across something like this, especially when you start natural language processing techniques. So this is a word cloud that provides areas, different areas. But this is for data science. So you can see from this, you see machine learning, statistic, communication, big data, natural. So these are all concepts or terminologies that has to do with data science. So data science is interdisciplinary. What do we mean? We mean it comes from different disciplines. So it combines different disciplines. So if you look at this here, the major idea of data science comes from what? Computer science plus statistics and then mathematics. So all the models that you will be using, the, let's say, neural network model, random forest, deep learning, and so on and so forth, they are built using the idea or concept of statistics, mathematics, and computer science. And then these concepts are now applied to different domains or different disciplines, such as the science, economics, sociology, business law, and so on and so forth. So it's good to understand the interdisciplinary concept or attribute of data science. And then data science versus data analytics and data engineering. This course, MSc AI, will initially focus on the technical and data manipulation aspects of data science, which we will be calling it data analytics, right? So some people also refer to it as data engineering. So at the end of the day, you will become data engineer, so data scientist or data analytics, whichever name you use is accepted. So data science is much broader and includes domain expertise, communicating the results to users via storytelling and visualizations and policy and legal implications. And we will get to the broader social context later. For instance, the data ethics, which includes or involve things like privacy, fairness, accountability, transparency, and so on and so forth. And we'll give examples throughout the course of how data science is used in different domains. Now, let's look at data analytics. So, our focus is managing and creating models from data at scale. So, when I say model, I mean AI models, data science models, or machine learning models, right? So not mathematical or physical models that we might be familiar with. So these models, or the data, they might be complex, heterogeneous, large, high dimensionality, velocity. So we will touch on many related techniques and issues, including machine learning, distributed computing, distributed algorithms, and parallel computation. And we will leverage standard tools and platforms and point to order. So there are standard tools and platforms that we shall be using to achieve this, let's say, to to utilize this high dimensional data in order to build or develop machine learning models. And some of the tools or the platform, I think Miriam has started showing you, the Google Colab is a platform that one can use uh, at no cost. There are, even though there are premium version of it, but you can use the free version to execute a lot of these things. So our focus is on the foundations of machine learning and cloud platforms. As I said, one of the cloud platforms is the Google Colab. So you should continue to study this in depth afterwards. Now, look at this workflow. That is data and model. This is just a typical workflow of data science. So the first thing is raw data, and you need to get the raw data. The major prerequisite for developing machine learning model is the data. If you don't have data, any project that you embark on, any machine learning project or AI powered project, you must be sure of where your data is coming from, because without data, you will end up doing nothing. Okay. So we need to have the raw data, and the data may come from either observations, sample from the world, or from some recordings, or from sensors. There are different uh, ways in which we acquire the data set. So these data sets, they might be structured and they might not be structured. All right. So structured, integrated data. So we need to work on the data set so that it can be interpreted by the machine. And that is what we call machine interpretable data. All right. So, and most of the time, this is what is referred to as data wrangling. And then after we transform the data, and then we do what is called future extraction, that is extracted future. So we will want to extract some important features that we want to use to develop our model. And for instance, this normally occurs when you have many features, and then you might want to go for some few features of the data set that might have a positive contribution to the output of the model. So uh, that are measurable characteristics. So we look at which feature is important and will contribute to the model development. And then after that, next is what we call descriptive or inferential model. That is the arc of developing the model. So you might want to develop, let's say, descriptive model or inferential model. We'll look at this later on in the subsequent slides. And that is you develop model of the population as a whole. So parts of the data may be in different system or organizations. So sometimes our data come from different organizations or from different systems. All right. So it might also be across different documents or databases. So also it is often not in a form where we can directly use it. For instance, it is in text documents, and then we want to develop a machine learning model that only accept data in numerical form. So we need to do a kind of some data transformation activities. All right. And also sometimes uh, not it is clean and regular. It might not be clean and regular. So sometimes it might have massive missing values and spurious values. So we need to do carry out some pre-processing activities, at least to impute where there are missing values, so that when we start feeding the data into the machine learning model, we will not encounter any difficulty or error. So our goal is to extract features that help us make predictions, right? So considerations around big data, structure, cleaning, and linking. So open and closed walls, observations versus the universe. Databases often assume a closed world. So, for instance, we know everything, right? Let's say a company's employee, let's say a database for a particular company might include the records of the employees in that particular company, and then their exact salary, what each employee earns, and then the product that is being produced in that company. So normally this is what we call a closed world. Okay, so it's really restricted to that particular company. So it's closed. It's not something that is only applicable to that particular company. Now, data science is an open world. What do we mean? We mean we can't see the whole population. So we are given samples or incomplete observations. That is what data science focuses on. You have some samples or incomplete observation, and then we want to predict the future or characterize the entire population using the available samples or incomplete observation that we have. So it's not close, right? So how we sample affects our model. There are many pitfalls that can lead to biased models. That is, for instance, a topic researchers are trying to address. And as the text says, past performance is not indicative of future results. All right. So you can't rely on past performance and then you say it's an indicative of future results. So certain things need to be done. And this is what you will be embarking on. You might have some samples or incomplete observations, and then you will develop models that will predict the future or will characterize the entire populations of that few samples that you have. Right, so raw data versus structured data. What do we mean by raw data? Raw data is just a data that you just collected and is yet to be processed. Okay, for instance, if you look at this, the first thing we have, and then this raw data may come in different forms. So look at this. The raw data might be an image. So we have an image of a cat here. It's a raw data. And then the raw data may be in form of genes. Okay, so this is just a representation of gene of a particular cat. And then the raw data may come in form of a text. And look at this text. It says, do not be like the cat who wanted a fish but was afraid to get his paws wet, by William Shakespeare. So a raw data need to be what? Need to be transformed and so as to become structured. So data plus future extractions or wrangling will now leads to a what? To a structured data. So this table here is just it says language is English, label is cat, that is where our raw data is coming from. Description, domesticated species of feline, it describing what cat is, also not known as house cat, and so on and so forth. Now, if you come here, there are some certain things that have been done here. So it's a bit tiny. This is a name of the breeds of the cats, and then the country where these cats are normally available, and then the origin, the body, the coat, which is short, and then the pattern is ticket, and then the image. So it gives, this is a description of this type of cat. So what are we saying here? There are different breeds or varieties of cats. All right, look at this is different from this is different from this is different from this. So but we need to get no information about each of these cats, and then it's this information that we will use to develop model that at the end the model will be able to predict different types of cats. All right, yeah. So goal is raw data to structured data. So when we get our raw data, we need to transform it to a structured data. And having fields, entities, objects, machine learning features. And then this may be very regular or semi-structured. So ultimately, goal is to go from data to information to knowledge. So from raw data, we want to what? Go to what? Information, and also derive knowledge from them. As I said, we get the raw data, we structure it, and then we develop the model, and then the model will be able to receive inputs for different what? Features of different cards, and then the model should be able to predict what type of card is that. Okay, so this leads us or takes us to what is called linking the data now. So we're trying to find patterns in connectivity, things that we normally refer to as clusters or paths. So if you look at this, it's something like we have some entities that are connected to each other. So this is a person and this is another person, and they are connected. So these are what entities and their relationship. You remember, if some of you are familiar with database, we have entities and then relationship. So this person is a friend to this person, and then this person like something, it is PS, and then is like, and then what type of cook they like is here. Also, what type of music they listen or they watch, Netflix, and this is also a friend to this, and then this also listen to Spotify. Also, all this is saying what different entities may, how different entities are related to each other. So this guy is connected, has a relationship with this as a friend, and then this has a connection with this through what they eat, through what they watch, and so on and so forth. And then next is another thing that we call knowledge graphs. So, for instance, knowledge graphs come to application when you have uh, complex data that that has complex semantics, all right, complex meanings or uh, complex patterns. So these data need to be what? Need to be organized in what we call classes, subclasses, instances, and properties. And so this is what we have. So if you have a class, certain things that have the same attribute, common attribute, and then what method, so you can group them as a as one class. Under that class, we can have subclass of it, and then we still further divide it or derive instances from it, and then from instances we have our properties. So for instance, you see example of property. This is from educational organization. Under property, you will have, let's say, alumni, and then expected type is a person, and then description is an alumni of an organization, and inverse property, so and so on and so forth. So under property, let's say address, if address is a property, this is what type of it, let's say postal address or text, and then description, let's say physical address of an item or physical address of a person and things like that. So normally we have, if we have data that has a huge complexity, which is very complex, we use what is called knowledge graph to gain information, to extract information and patterns from such complex data set. Another type of data set that you might come across is what we call temporal data set. So in other words, they are called time series data sets. And time series or temporal data set, they are data that give us an idea of what happens over time. Now, they sometimes they are called dynamic high velocity data, and then you track them over time, and then they can be used to forecast the future. So this image that you see that is changing is a prediction of temperature in different parts of the world. Okay, so it might give you the year and the time. You might not see it, but uh, it may give you the year and then the level or the intensity of temperature at a particular zone over time. All right. So this is what is called temporal data set, and you will come across different techniques that you will use to leverage this type of data and then to come up with important information or future prediction. And what about tabular or relational data and joins or lookups? For instance, uh, to web services. So some data set, they might come up in a tabular form, and this is one example of it. For instance, you have a column. So when we have columns, this is what we call the futures or variables, and then they are in rows. So normally tabular data sets are described in form of rows and columns. So the rows represent the samples. So in this case, we have 1, 2, 3, 4, 5, 6. We have 6 samples or 6 records of this data set. And then the columns represent the attributes or the features. So 1, 2, 3, 4, 5, 6, 7, 8. For now, we can see 8 attributes or features. So look at it, passenger count 1, and then trip distance for the first sample were 15.5, pick up longitude, pick up latitude, postcode ID, store and forward flag, drop of longitude and drop of latitude. So this is a data set of a New York taxi data. All right. So this is an example of a tabular data set. You can use this data. You can apply different machine learning algorithms to derive information from this data to predict certain attributes or features of this data set. So next, if we look at this data set, there is what we call geocoder. If we can use geocoder and then take some input from this data set, and then this geocoder is a model, it's also it's like a machine learning model. So it will give us what? It will predict something for us. Now, for instance, look at what is happening here. If I click next. All right. So look at it. If we take two attributes as input to this geocoder model, so we are just taking the longitude, the pick up longitude, and then the pick up latitude. Let's say you've been picked by a taxi driver. So if you know where the longitude where you have been picked and then the latitude of the pick up, these are just two attributes. And then you imputed these two attributes here and see the information that this model is generating. First, it will give you your location. Say, this is your location. All right, that is the pickup longitude and then the pickup latitude describe your location. And then it will now come up with information. This is the nearest street address. So it will tell you the name of the address of the street where you have been picked. And it's saying 393 Fifth Avenue, New York. This is the address of where you have been picked. And then it also gives you information about neighborhoods. So you are neighboring with Tenderloin, New York, and then Tudor City, New York as well. So this is what model can do. So, but you need to have the data. So this model has been trained and developed. So all that you need to do is, for instance, this is the data that has been used to train. So if you have this type of model, what you need to know is just your pickup longitude and latitude. Even if you don't know the address where you are, just impute your pickup longitude and latitude. The model now will tell you the address, a particular address of your location. All right. And then next, you can go further because the address is a hyperlink, which means if you click at the address, it will now take you to a map, a Google map, and then it will show you even the particular place. So look at it. Clicking at this link take you to the street view, so you can visualize the street at the street of your location, not only text. So this is it, and you can even see a taxi in front of this particular building. So this is the street of this particular address. So what are we saying? That is how to leverage a data set, develop a model, and then have predictions. What the model will predict. So many informations. You might decide to, let's say, make use of other attributes here apart from the pickup longitude and pickup latitude, and then predict something else, right? So we only use this model only use two of these attributes to now predict our information or generate useful information, which is the address of the street where the passenger was picked. Now, what makes data big? Now, the concept of big data. You must have come across this terminology, big data, big data, big data. So, yeah, is it a gigabyte? That is a million records? Is it a petabyte, billion records? Is it a yottabyte, trillion records? What really makes a data big? Right. So there is no consensus definition, but from our perspective, we can say a data that is too complex for human to understand directly can be referred to as big data. All right. So this type of data, they doesn't fit into a single uniform memory space. For instance, they might not fit into a variables in Python. So it means we need to think carefully about the input and outputs and all the communication, right? And this type of data, they need more than something that we call brute force algorithms to analyze it. So brute force, something like just they need more than just a simple algorithm or just a Excel spreadsheet to analyze them. They are very complex. They are very huge. They may require multiple computers to work in parallel to process them, and then possibly they may have high dimensionality, high dimensional data, which require future selection and dimensionality reductions before they can be fed into a particular AI model. Uh, they might be changing rapidly, high velocity, like the temperature data that we see. They may be changing rapidly, right? So the temperature data, you can use it to understand the climate change. So this type of data, they might be referred to as big data. And so what does data analytics involved? If we now understand different type of data, temporal data, complex semantic data, and then big data. So what does data analytics involved? The goal of data analytics is to make a transformation from raw data to knowledge or action. That is the goal. So it's just data analytics is all about transforming raw data to a knowledge or an action. That is from raw data to what? To information. One of it is what we call pattern detection. How do we detect pattern from raw data? All right, so from raw data, patterns, then you may have some partial knowledge or partial understanding of what is going on there. For instance, you see sales by region, by product category. Let's say if you have a data set that has to do with sales of product for a particular company, so data analytics will help you to see sales by regions or by product category, if that is the information that you are looking for. It might also help us to cluster this data. If let's say if they are documents, so we can have clusters of them by concept. So let's say I want to cluster them by a particular concept. So clustering is just like grouping them by a particular concept. All right. And then there's what we call data cubes. Sales by region, by quarter, by type of product. And then typically we can use descriptive statistic to achieve this. There are descriptive models or machine learning models. We can use them to achieve that, right? For instance, the clustering algorithms, some of these linear or logistic regressions can suffice when we want to derive patterns and to get some partial knowledge or information from our raw data. And then uh, another way, if given observation, let's say if you have your data coming from observation, you remember different ways we can source our data. Observation is one of them. So if we have some observations, we can now develop some hypotheses. That is what we call experiment in machine learning or in data science. So first we need to develop we come up with some hypotheses, and then we experiment over sample, and then this lead to what? Significance. Okay, so behavioral factor, let's say behavioral factor F leads to higher risks of outcome O. This might be one of the outcomes that we might have, but we need to have the observations. We need to carry out the experiment before we'll come out with this kind of information. Or sometimes we may have this question: do statistical tests measure significance versus null hypothesis? Typically, we will need some statistical methods or tools. Mostly inferential statistic will be used to achieve this. All right. So what does big data analytics involved? First, these are, let's say, like some of the steps that you need to carry out when you are conducting a big data. Want to do analysis on a big data. So first, you need to acquire the data. Data acquisition is the first thing, right? So you need to have access to the data. So data may exist without being accessible. So you need to find access to that particular data to acquire it. And then you perform what we call data wrangling. So because data may be in a wrong format, so you need to carry out data wrangling in order to transform the data into a way that will be accepted by the model. And then next is integration or representation. So this is data relationships may not be captured. So you need to carry out data integration or representation in order to capture the relationships in this data. And then next we have what is called data cleaning or filtering. Data may have variable quality. So the data might not be clean. So you need to carry out some cleaning processes, filtering processes to have the data cleaned or filtered. And then there is what we call hypothesizing, querying, analyzing, and modeling. That is from data to information. So this is the real work. This is where you develop the model, you carry out some experiments, and then to see what information are contained in this raw data. And then after that, you are building knowledge now, helping build knowledge. So you understand iterating, exploring. So when you build the model, you may want to now see the output of the model. You want to visualize the output of the model. That is to understand the output of the model, right? So that is you are building knowledge. And then next, which is almost last, what we call ethical obligations. So you need to protect the data, follow good statistical practices, present result in a non-misleading way. This is very important. AI ethics, I think it's one of the modules that you will take in the course of your study. So you don't just go and get data that contains some ethical consideration and start developing model and publishing your model. You are breaching the data protection law. So you need to the ethical process of and also you need to abide by all the rules of all the ethics that are associated with the particular data set that you are working with. Right. So moving forward, these are just some examples of what has been done before. You can Google this and you will find more information. Example is Netflix recommendation. This is one of the competition that was launched, I think some years back. I can't remember. So this is just a slide. I'm in a slideshow mode, but if I'm in the row, if I exit this slideshow, and we can click this and then see, sorry, this is just an image. If you are on the website, you click, you will see more information about the Netflix competition that was launched time before. And these are the names of the team name, and then their score. So I think this is the top scorers. They almost have the same point, the same predictions accuracy, and then improvement, and then best submit time. This is the time that they submitted. So they use a data set from Netflix, I think, to develop a recommendation system for Netflix users that will recommend 1 to 5 star movies, I think. So this has been completed, and these are the teams that participated in this competition. And this is another example. It's called high throughput gene sequencing, and the paper is available in Nature. The paper was published by Nature, and then they use, I think, they use data set from genetic informations, so which is a very complex. So by this right side, you will see is the working process of the model and all the workflow of the model, what has been done. There is filtering, transcript, aligning, ranking, and so on and so forth, to data formatting, protein, and so on and so forth. So it has to do with gene, biological, that is application of data science into biological processes. And another example, no, we don't have another example. Data science and data analytics are be aware of overhype expectations. So there are myths and realities when it comes to this issue, especially AI. There are myths and realities about AI, and you need to be clear with these things. Otherwise, you might easily be misled. So some of the myths includes, you will hear people saying we learn everything bottom up using fancy statistic and machine learning. This is just a myth. And the reality is we will typically rely on human expertise to impose models over the data, the future, and so on and so forth. So it requires human expertise. That is why you are in a good place, I think, and you have taken the right decision to go for this particular course, MSc AI. Most of the time, you hear people are afraid that AI will take over jobs, but it requires human expertise. It requires people who are expert in the field of AI. And another myth is basically we turn the crank and out pop insights. This is just a reality. Sorry, it's a myth. And the reality is deep learning can do future selection, but why throw away what we know? Okay, so data plus algorithms, question mark, will that give knowledge? This is just a myth. The reality is you need, if you have data, you need human insight, you need algorithms, iterations, and this will lead to information and knowledge, right? So data science application process, that is if you are embarking on a data science project, what do you need to be aware of, or what questions do you need to be asking yourself? So anytime, maybe at the end of this course, you might do your final project. So these are some of the questions that you should be asking yourself. What question are you answering in that particular data science project or application that you are developing? And then what is the right scope of the project? Your project need to have a scope. Otherwise, you will end up doing something that will go to, without end. And then what data will you use? What type of data? When you start your course, you will come across different type of data. So you need to understand what type of data you will be using. And then once you understand the type of your data, that will lead you to another question now. What techniques are you going to try? Okay, so when we say techniques, we mean data science techniques, AI techniques, or machine learning or deep learning techniques, because different techniques go, you cannot use. There must be a compatibility. The data that you work with will determine the type of technique that will give you the right results. Okay, and then next is how will you evaluate your results? That is what we call model evaluation now. So there are some metrics that you will need to know, and then you will use them to evaluate the result of your product or of your application. And then what maintenance will be required. So it's not enough to develop the model, get the result, and evaluate the result. The model need to be maintained. And the question is, what maintenance will the model require? And then, so disclaimer and recap, we are almost done. I will reserve like 10 minutes for questions and answers. So, a word from practitioners in data science, they say at least 80 to 90% of their work involves not machine learning, but working with experts to understand the domain, assumptions, questions, etc. For instance, at the end of your course, you will become a holders of Masters of Science in Artificial Intelligence, and you will be using your expertise to solve problems in different domains. So you will need the input of experts from different domains that you want to apply your skills of data science. And then also they say trying to catalog and make sense of the data sources, wrangling, extracting, and integrating the data, cleaning and wrangled data. So these words are from what? Data science practitioners. But the most important thing, as I say, is you need you need the domain expert to work with. So you can see where this particular discipline is interdisciplinary. So recap, what data science involves? It involves, we say data is high dimensional, hard to understand, and requires an understanding of computation and input and output costs. Given an integrated data set, often the hard part, data science involves extracting and selecting features as well as adding semantic structure to the data. And then we say there are many applications of data science, from discovery to clustering to classification to recommendation. What we have just seen regarding the cart is what we call classification problem. So there are different application of data science: classification, image segmentations, predictions, and so on and so forth, recommendation systems. All right. So sometimes statistical, sometimes algorithmic, sometimes reliant on extraction. So there are different application of it. Okay, right. So I think this is the last slides that we have, and as I said, we have 10 minutes to attend to question and answer. So if there are, let me check now let me stop sharing and check the chat. If there are some questions that you guys have dropped, then we will answer them and then close this section for now. All right. So where are we starting? Yes, this is a concern of mine. Do you think AI will eventually take over the roles of data scientists themselves? This is what I was saying before. AI, all that you see, data science is part of AI, okay? Because you will be using the AI tools. So all that, if you look at the robotics, that is the real core AI of AI, the robotics and any other AI that you may think of, they cannot perform well without data. The robots that you see, they were developed using data. So if data is the core, is the center, is the requirement, then it is impossible for AI to take over the roles of data scientists. So even the core AI and data scientists, the data science cannot be separated. They are two things. They are things that must work together. Okay, so you as a data scientist, at the end of the day, as I said, you will be an holder of Masters of Science in Artificial Intelligence, but you need to what? You are also what? A data analytics. All right, and then you can call yourself a machine learning engineer or an AI application developer, whatsoever you may think of. But all that we are saying is, for the field of AI to keep advancing, it requires the human expert. And that is why we are keen to training more artificial intelligence experts. And this is one of the major focus of this particular course. So you will be trained as the future AI experts that will really be needed for any AI application to be useful and helpful in this world. So what is meant by adding semantic structure? Semantic structure, where do you get that question from? Can you remind me, please, so that I cannot be explaining things that are irrelevant here? So in related to what? When you say semantic structure, in my slides, okay, the classification system, right? Okay, so don't worry. Let me see, because semantic might be one before. Okay, before the last slide. All right. So we say trying to catalog, extracting insight. That is slide number 30. Wrangle. There is a place where I spoke about semantic. Okay, so let me not even let's not waste time. Semantic means meaning. Okay, so semantic structure, that is, you are transforming your data set into what has a meaning. As I said, if you get the raw data, if you start this, you will find out you may have your data in form of images, in form of text, in form of numeric values. All right, so sometimes we refer to them as unstructured data or unorganized data. Let me use these words: unorganized. So in simple form, semantic structure is like you are making it, organizing your data, all right, giving them a structure. You can refer to structure like organizational structure. So semantic structure, that is the data, the meaning of the data is what is organized in a way that is ready to be fed into a machine learning model. Okay, so you are just having some meaning or extracting some meaning or giving some meaning to the data set, and then you are trying to organize them in a way that will be ready to be used for developing any AI or machine learning model. I don't know whether that has helped, please. Is it Nasir? Right. Uh, is this good for those who have studied MSc Cyber and use recognition inaccuracies as project? Oh, thanks, Nasir. So, is this good for those who have studied MSc Cyber and use recognition inaccuracies as project? Is this MSc worth studying, or is it better for new? No, it's not only for newbies, man. Craig, it's not only for novice or for newbies. If you have knowledge of cyber, or is it cyber security or any other thing, and then having this knowledge of MSc AI will be a huge advantage, I believe. All right. So because you may find some situations where you need the expertise or the knowledge or the skills of AI or data analytics to solve some of the cyber issues. So it's well interconnected, and also uh, it has advantage. It's not only for newbies. You hold MSc in cyber. Can AI be used to write mathematical proofs? AI, any AI model, let me say, is garbage in, garbage out. So if you talk of AI to use some write mathematical proof, I think as we speak now, we have a lot of things being developed. You will be surprised what AI models can produce. It can write even more than mathematical proofs, but it needs to be developed. So, and this is what we want to train you to do, to know how to develop models that can do extra things. So the answer is yes, Craig. But you need to develop it so that it will require input. Now, if you say mathematical proof, so I have just shown you one model that requires two inputs and then generates information, like it requires the pickup longitude and the pickup latitude, and then it generates the address of a particular street. So if you want to develop a model that will perform a mathematical proofs, then you need to know where your data will be coming from, what will be now the input to the model, and then you can develop the model. So the user will only require the input to input into the model, and then the model will generate the mathematical proof. So this is what you need to learn, and then what it requires to develop this type of model, and what are the best practices needed to develop this type of model, right? Can you provide a link where all the lectures will be posted, including this one? All right. You guys, if you are fully enrolled in this course, you will have access to Moodle. Do you have access to the Moodle page at this moment? No. Okay, so please don't worry about that. I will not I will not provide it at the spot at the moment, but if you complete your enrollment, there is what we call Moodle, where you will have all the modules, access to all the modules that you will be taking in the course of this program. So it's a, what do we call it, learning management system, or learning management system. So in that particular platform, you will have link to all the materials and even other resources that you can use at your own convenient time. Lecture slides, lab sheets, and any other thing. If there are sample data set that you'll be using, you will have them all posted there. So don't worry, please. I think by still the module rollover is on, and before you start, you will have access to them. All right. I will miss part of tomorrow lecture as I have an appointment. No problem. I think it will be recorded, Fatima. How will I catch up? So every section will be recorded. So you should be able to visit the Teams channel to listen to the recording. And also it will be posted on a YouTube channel, which Mariam has said it in the morning. So you can catch up by listening to the recording afterwards. Are there further questions? Okay. So I think we stop here, and I will stop the recording, and Mariam will upload the recording to the YouTube channel, and you should be able to listen to them afterwards. And I'm not sure what you have next from 3 to 4. If you have the schedule for today, you should be able to know what you have from 3 to 4. But I am asked to cover this section from 2 to 3, and I hope you find it helpful and you enjoy it. Looking forward to meeting you face to face, and then I believe you will enjoy your stay. Enjoy the rest of the day, and thanks for joining.